number 1. In the instructions, it says, because of the instructions, it says find all the real square roots of each number. We've got to find both plus and minus if that's applicable. So since these are square roots, all even roots have plus and minus answers. So the square root of 36, we should just type it into our calculator. Now if you get a decimal, that is when you should be saying to yourself, I need to go back and do it by hand now. Now that we're in secondary 3, if you get a decimal when breaking down radicals, you got to go back and do it by hand because we'll want the pretty answer. Square root of 36 is plus and minus 6. Now why is that the answer? Well, that's because 6 squared equals 36 and negative 6 squared equals 36. So that's why it's plus and minus 6. Correct, everybody? Okay, now next one. A lot of people are saying the answer is negative 10. That is wrong. Everybody look. This is a square root of negative 10. Technically, our answers are plus and minus what? 10i. Correct, everybody? Now, so try typing that into your calculator. The square root of negative 100. It says error. That is because we cannot take a square root of a negative or else it's I. So our answer on this one on the test should have been no real roots. We're not technically solving these, we're just simplifying these. Does everybody understand? Even roots cannot have negatives underneath. We're not dealing with imaginary numbers in this unit. Questions on any of those others in that section? Okay, let's go on to 5 and 6. Now, if you did not put absolute values in the correct place, I went back and gave you, points back. So we're just going to practice that today, making sure we have absolute values. So I still gave you points even if your absolute values were not correct. So everybody look up here. Number 5. Cube root of a to the 9th, b to the 12th. So we know that we're looking for groups of 3, correct? How many groups of 3 are there in 9? 3. It came out evenly. So right here, this became a cubed. Then how many groups of 3 are there in 12? 4. Was there anything left under the root? No. So then you say, that is my answer, but do I need absolute values? The only time we need absolute values is if you have an even root and odd exponent. Is that an even root? No, so we don't need absolute values. Okay, moving on to number 6. This one is a square root. Now, here's the difference. I did not clarify this to this class. I always learn from you guys and then go clarify things in the other class. So I want to clarify something. If I ever give you, so look down here. If I say to you, what's the square root of 9? The answer is simply it's called the primary root. It's just going to be 3. It's all in the wording though. If I say to you, find all the real roots of 9, that's when you have to put a plus and minus 3. Does everybody understand that? So look at the difference. If I say to you, what's the square root of 9? It's 3. If I say to you, what are all the real roots of 9? You'd say plus or minus 3. So when simplifying, we don't need to put plus and minus. All right, so the square root of 16 is, we're just simplifying, 4. And then b squared, square root of b squared is b. Now let's check. Even root, yes. Odd exponent on your variable. We only ever need absolute values on a variable. Isn't b technically b to the first, guys? Isn't 1 odd? Yes. So we need to add absolute values around b. Okay. Next one, number 9. A lot of people got number 9 wrong. A lot of people put i's. No, actually, I don't know if anyone in this class did. Cube root of a negative, isn't that absolutely okay? Odd roots that have a negative underneath have negative answers. So we need to make sure to pull out the negative. It doesn't stay under the radical. Did everybody hear that? Okay, now I like what I saw. Some people started to, oh no, this is not the one that most people missed. It was 13, but similar, so you'll be able to fix 13. Anyways, oh, this is not, yeah, this is number 9. Okay, so 343 broke down into 49 times 7, correct? 49 breaks down into 7 times 7, and now we're pulling out groups of 3. There's a negative, so it's just going to be a negative answer, negative 7. And then a cubed, cube root of a cubed, root cancels out with power there and gives us an a. Even root? Nope, so we don't need absolute values. Number 10, look at the original problem. It's a fraction. Your answer would need to be written as a fraction. Let's all practice typing this into our calculator. Hit 4. Go down to x root. Did we do it? 1/2. Okay. Now this is how we could have thought of it as well. The 4th root of 1 divided by the 4th root of 16. The 4th root of 1 is 1. The 4th root of 16 is 2. So we have 1 over 2. Did everybody see how I did it using just my head? Now we have to remember, since the instructions say find all, simplify each radical expression. So this one we don't need plus or minuses, so we're just simplifying. We go with the primary root. Because of the instructions, we're just going with the primary root. Okay, then 26, flip to the back. 26, it says, the voltage V, we have to get better at solving things that are really just plugging things in. Because on your ACT, you're going to get a few problems where literally it doesn't take any thinking besides being able to say, where do I plug this in and what do I solve for? So it says the voltage V of an audio system speaker can be represented by this equation. V is equal to 4 square roots of P. A lot of people ask me about a 4th root, so this is how you know. If 4 is not tucked in there, it's not a 4th root. That's 4 times the square root of P, where P is the power of the speaker. So it says, an engineer wants to design a speaker with 400 watts of power. So if this is 400 watts of power, isn't the power 400? So plug that in for P. It says, what will be the voltage? So we're looking for V. So we don't know the V, so question mark's equal to 4 is the constant, square roots of P. This one we happen to just plug right in. So then you'll take your calculator. You always make sure you do the square root of 400, which is 20. So we have 4 times 20, which is 80. So there's our answer. Square root of 400 is 20. 4 times 20 is 80. So voltage is 80. Does everybody get it? Okay. All my examples are coming off your worksheet, so I would be just following right along. Here we go. It says simplify each expression. So we know that a rational exponent can be written as a radical. That often helps us. So everybody look at number 1. We have 125 raised to the 1/3 power. I do want you to type that into your calculator. Everybody ready? Type in parentheses 125, close your parentheses, raised to the 1/3 power. What did you get? 5. So your calculator did it for you. However, that's how you should be checking your work. So let's do it by hand now. So what we would say to ourselves is, we know this is a rational exponent. It can be rewritten as a radical. So let's rewrite this as a radical. Roots are on bottom, power's on top. So this is really the cube root of 125 to the 1st power. Correct, everybody? So then we know that 125 breaks down into 25 times 5, and then 5 breaks down into 5 times 5, and then we're pulling out groups of 3. So we get 5. Does everybody see how we did it by hand? Okay, let's look at number 4. We can look at this a couple different ways, everybody. We have 7 to the 1/2 times 7 to the 1/2. Is this the same base? When you multiply the same base, what do you do with your exponents? You add them. 1/2 plus 1/2 is, so we have 7 to the 1st. Does everybody see how I did that? Pretty easy? Now another way to think of that is this piece, everybody watch, this piece is really the square root of 7, rewriting it as a radical, times we have the square root of 7. So now because they're both under the square root, we can put them together. So that's a square root of 7 squared. Isn't 7 times 7, 7 squared? 7 times 7 is 7 squared. Root cancels out with power. You get 7. Everybody good with those? Pretty simple. All right, let's do number 11. So you should ask yourself, it says simplify. Can I simplify these? Now originally when we look at these, do you see how 12, 45, and 50, we do not have the same base? Correct. Okay. But isn't it true that this is the same thing as the cube root of 12 times the cube root of 45 times the cube root of 50? So we rewrote it as a radical. So now you would say, oh yeah, I remember that if you have the same radical, you can multiply them together. Now make sure you're not making your life harder. This is really the cube root. I'm just going to leave it apart. 12 times 45 times 50. I'm not going to actually multiply that out because then we'll re-break it apart. So let's break this down and pull out groups of 3, because if I am forcing you to show your work, you're going to want to go about it this way. 12 breaks down into 4 times 3. 4 breaks down into 2 times 2. Is everybody with me? 45 is 9 times 5. 9 breaks down into 3 times 3. 50 breaks down into 5 times 10, and 10 breaks down into 5 times 2. I'm going to go through, since there's so much going on, and make sure I don't double dip. So I'm going to cross out things I've rewritten as other factors. 4 I rewrote as 2 times 2. 9 I rewrote as 3 times 3. 10 I rewrote as 5 times 2. Now, because it's a cube root, we're pulling out groups of 3. So we'll pull out a 3 for those 3 threes, correct? We'll pull out a 5, and it looks like we'll pull out a 2. So we pulled everything out. Oh, wait, did we pull everything out? Yeah, we did, right? 5 times 3 times 2. So that's 15 times 2, which is 30. Very good. So that's doing it by hand. Okay, number 5. Can anyone tell me what this is right off the bat? They're all cube root, so can anyone tell me the answer right off the bat, just looking at this one? Yeah, you're right. How'd you get that so quick? You're right. The answer is -5. Perfect. So 1/3 plus 1/3 plus 1/3 is 3/3. So -5 to the first. Very good. Everybody good with that one? No, you wouldn't, in fact. So you would write just -5. Very good question. All right, so do 1 through 12. Let's move on to the next section. So if you're not done with that section, it's all going to be okay. Skip with this. Just look back up here. You'll have some time to go back. Do not keep working, or else you're going to be lost. So it says, write each expression in radical form. So remember that rational exponents can be written as radicals. We have our picture of our flower. Cutest flower ever. There's the sun. So power's on top and roots are on bottom, correct? All right, so look at 21. We have a to the -1.6. Well, first of all, this isn't a fraction, so we don't know the power or root. So everybody in your calculator type in -1.6. You're going to have to hit enter. Let's all do it. -1.6, hit enter. Then hit math, enter, enter. Change it back to a fraction. -8/5. So I'm going to rewrite this as a to the -8/5. I'm rewriting it as a fraction because then I can rewrite it as a radical. So first of all, notice this one has a negative exponent. So the first thing we're going to do is say we shouldn't have negative exponents. Let's flip it over a fraction. So we take it, flip it over a fraction. So that leaves me with 1 on top, correct? And then on bottom we have a to the 8/5 now. So now we can rewrite it as a radical. Roots go on bottom, power goes on top. So we know this is the same thing as 1 over roots go on bottom. So 5th root, tuck the 5 in there, of a to the 8th power. And you can just stop there because we're just doing what the instruction tells us. It says rewrite it in radical form. We've done that. So we're not going to keep simplifying it unless it just says simplify. Yes. This one only has 1 base, so we wouldn't need it for this one, but that's a good question. Okay, so do 13 through 30. On number 25, we're looking at this, the cube root of 2y squared. Okay, so you'd say to yourself, is 2 raised to the 2nd power? The answer is no. Okay, so only y is raised to the 2nd power, but they're both under a cube root. So we have both 2 and y squared, and they're both under a cube root. The same cube root, correct? So we put our 3 down here because it's a root. So what power on top would help us not change those powers? 1. That's what you're saying. 2 is and y squared, not together because 2 is not raised to the 2nd power. Those are the under the 1 over 3rd, sorry, the cube roots. The cube root. Sorry, I said that word. Does everybody see the difference between that and, let me show you. So if we had this, let's go this way. 2 times, sorry, if we had 2y to the 2/3. This would be, let me show you, everybody look at this. This would be 2 cube roots of y squared. Because do you see how y is the only thing raised to the 2/3 power? Does everybody see? Then if it was this, 2y to the 2/3, then we'd say both are under the cube root and both are squared. And then if you have this, if you had that, you would say they're both under the cube root. If we were starting here, because we were going from rational exponents to radicals in my example just a second ago, they're both under the cube root, and then we have 2y squared to the first, which is just cube root of 2y squared. So make sure you can see the difference between those. All right, let's move on. So here we go. It says write each expression in the simplest form, assume all variables are positive. So with that in the instructions, we don't have to put absolute values. So we're simplifying these. Every problem you'll say, how should I simplify it? So 32, let's do it the easiest way possible. What is the answer going to be? 81, correct? Raise the power to a power and you multiply. Or we could think of this as the fourth root of 81. The fourth root of 81 to the fourth power, correct? Root cancels out power, correct? So we have 81, or raise the power to a power and you multiply. 1/4 times 4 is 81 to the, is for 1, 81 to the first. So our answer is 81. 38, it says, write each expression in the simplest form. Are we multiplying the same base? So you'll add your exponents. Take your calculator, do 1/2 plus 1/3. Yep, so we have x to the 5/6. Now, here's what you'll, this is how you'll know you're done. If you started with rational exponents, then your answer will stay in rational exponents. So we're done. We don't need to rewrite it as a radical because we didn't start as a radical. Let's look at 39. Isn't this, we all know that this is just 2 times y to the 1/2, correct? Times y to the 1, right? Okay, let's simplify this. 2, nothing to simplify with 2, correct? So we have a 2. When you multiply the same base, you add your exponents. 1 plus 1/2 is, but we write, in secondary 3, we never write mixed fractions. So, no, we don't write decimals if we start with fractions. So take your calculator. Do 1 plus 1/2, math interventor. So we have y to the 3/2. We can stop here and not rewrite it as a radical because our answer didn't start as a radical. It started as a rational exponent. Okay, 47. This is properties of exponents. We have all this stuff being raised to the second power, correct? Now, because there's no, everybody pay attention, because there's no addition signs in here, it's okay to raise all of those to the second power, correct? This is not breaking the forbidden rule. Okay, so we have 3 to the second, a to the, raise the power to a power and you. Okay, 1/2 times 2. 1/3 times 2. 2/3, guys, you multiply fractions straight across. Does anything more simplify? 3 squared is not 3 times 2. 3 squared is 9. Then we have an a and a b to the 2/3. We've got to be really good at properties of exponents. So not bad, guys. These are secondary 1 level. Questions? Okay, let's look at 52. You can do this a couple of different ways. How I just think of it is, every single base in here is raised to the 1/2 power, correct? So I'm going to do 12 to the first, 75 to the first. Okay, raise the power to a power and you multiply the powers, not the base, right? So 12 to the 1 times 1/2. We're multiplying, not adding 1/2, right? 1 times 1/2. So we have this, 12 to the 1/2. Now, for this piece, 8 times 1/2 is 8 over 1. Multiply across. 8 over 2 is, so we have x to the 4th. Now on bottom, don't we have 75 raised to the 1/2 power? And then on bottom, we have y to the 5th. So you say to yourself, there's my answer, but does it simplify? Well, numbers raised to a power simplify. If you get a decimal, that would not be acceptable. So, a couple different ways to do this. I would think of this as a square root. Well, actually, let's do this. I'm curious. Take your calculator and do, everybody ready for this? Do 12 raised to the 1/2 divided by 75 raised to the 1/2. And then change it back to a fraction if possible. And if it simplifies for us, we won't have to do this any much harder. 2/5, perfect. So this became 2/5. Did everybody get 2/5 though? If not, then we need to help you type it in correctly. Did we all get 2/5? So this became a 2, this became a 5. Okay, sweet. So we have our final answer be 2/5, x to the 4th, y to the 5th. Does everybody feel comfortable with those? Okay, I'm going to give you a second to do 32 through 52. So, we've already learned this stuff. We're just doing more advanced now. So it says multiply if possible, then simplify. We can multiply if two things happen. If we have the same radical, square root, cube root, or if you have the same base, correct? Because then it's just properties of exponents. Okay, here we go. Let's look at number 1. Square root of 4 times square root of 5. Can we put them together? Yes, both square roots. So write it as the square root of 4 times 25. Do not actually multiply those out or you're making your life harder than it needs to be. 4 breaks down into 2 times 2. 25 breaks down into 5 times 5. Pulling out groups of, so we'll pull out a 2, we'll pull out a 5. So my answer is 10. By hand. Number 3, can we multiply these together? So square root, cube root. This is a 3, this is a 27. Now here's where it's tricky. This is really the square root of 3 times the cube root of 9 to the what power? No, actually, that's not true, correct? Because 9 to the 3rd power is not 27, right? It'd be huge. So let's see here. Can we rewrite 27? Sorry. Let's see. 27, can we write it as base 3? Because isn't this base 3? What's 3 to the 1st? 3. What's 3 to the 2nd? What's 3 to the 3rd? 27. Okay, so we'd say actually we can secretly, this is one of those tricky ones, even though it looks like the root's not the same, the base is the same, it's just in disguise. So let's rewrite this. The square root of 3 times the cube root of 27 is 3 cubed, so we have 3 to the 3rd. Okay, let's simplify this the easy way. Root cancels out with power, correct? So we just have 3 times the square root of 3. 3 times the square root of 3. And we could have just seen right here, basically, that the cube root of 27 is 3. So 3 times the square root of 3 is 3 squared root of 3. Does that make sense, everybody? I kind of made that harder than it needed to be. Everybody good? Okay. Moving on to 7. It says simplify, and I'm adding these in. Erase the part where it says do not. It says all variables are positive. I'm having you cross that out. We're going to use the absolute values because we need to practice. So number 7 and 8. Let's do these. So number 7, 36 breaks down into 6 times 6. And we're pulling our groups of 2, so I'm not going to keep breaking that down. So when we pull out a 6, 6, and then we'll pull out a x, and left under the root was x. Any questions on how I got that? Let's check if we need absolute values. Even root? Yeah? Odd exponent. So we need absolute values. Now you never put absolute values underneath the radical. So it's just on the outside here. Everybody comfortable with that? Moving on. Number 8. 125 breaks down into 5 times 25. And 25 breaks down into 5 times 5. We're pulling out groups of 3 this time. So we'll pull out a 5. Now y squared. Can we pull out 3 of those? Nope. So I'm going to go off to the side, and you're not going to make the mistake. Today you're going to be really careful. Do not write square root. I will mark that wrong on the test. It's a cube root. So put the 3 in there. Left underneath was nothing with numbers. There's a y squared left underneath. Now let's do z to the 4th. We'll pull out a z, correct? What's left under our radical? Good, z and y squared. Here we go. Do we need absolute values? Even root? Nope, so we don't need absolute values. Okay, moving to 17, and then I'm going to let you just go at this page. So next section here. Once again, see how it says assume all variables are positive? Cross out that, and we're going to put in absolute values. We want to practice. So we're going to put in use absolute values when necessary. So let's do this one. So 17, we have a square root of 9x squared times the square root of 9y to the fifth. Can we multiply these together? Square root, square root. So what you're going to do is write it under the same root. We have a 9 times a 9, true? We have x squared. We have y to the fifth. And now you'll simplify it. I didn't multiply those together because then I re-break them down. If you didn't multiply them together, though, you're fine. You're just doing extra work. Yeah. Okay, perfect. So we'll pull out a 9. We'll pull out a x. And then we'll pull out how many y's? 2. There's 2 groups of 2. So we'll pull out y squared. And then left under a radical was a y. Very good. So you'd say, do I need absolute values? Did it start with an even? Look right here. Even root. Odd exponent on x. Yep. So we need absolute values on y. It is not an odd exponent, so we don't need absolute values. The square takes care of any possible negative. So this would be our final answer. Good. All right, let's do another one that's a little bit more advanced, number 18. So cube root, we're multiplying. So we can put this underneath the same cube root. Here we go. Everybody watching very carefully. Cube root of 50 times 15. I'm just going to leave them apart. So 15 times 50. Now we have an x squared. Any other x's? Nope. So x squared. We have z to the fifth and a z. So how many z's do we have? Z to the sixth. And then we have our y cubed. Was that too fast? Pulling out groups of 3. So 15 breaks down into 3 times 5. 50 breaks down into 5 times 10. 10 breaks down into 5 times 2. Pulling out groups of 3. So we'll pull out a 5. Okay, I'm going to go over here and pull out 5. Then I'm going to go over here and give myself some room, put a cube root, because I don't want to get it wrong. Left underneath for numbers was a 3 and a 2, so a 6, correct? Okay, let's move on to the variable part. I'll change colors here. So x squared, can we pull out anything? Nope, so we still have x squared. Z to the 6, how many groups of 3? 2, so we'll pull out z squared, very good. Y cubed, and cube root of y cubed is y. So there's my final answer. Even root, nope, so we don't need absolute values. Not too bad, right? See, today they're just a little bit more advanced, but definitely doable, right? Okay, awesome. 24. Notice, we're multiplying some stuff here, but notice there's a 7 and a 2 already on the outside. Don't let that throw you off, because this is just, multiplication can be reordered in any order. So just think of this as 7 times 2 times the square root. Now we can put them under the same root. So we have a 3 times 6. We have a y squared and a y. That's y cubed. And then x cubed. So now I can simplify it. But do you see how really it's not bad? You just look at it in sections. So right now we have a 14 on the outside, correct? We have a square root of 6 breaks down into 3 times 2. So when we pull out a 3, so pull out a 3. Left is a 2. I need to give myself some more room here. So we had 14 times 3. We just pulled out a 3. I'm going to give myself some room. It's a square root. We're good. So left underneath was a 2. Y cubed. So square root of y cubed. We'll pull out a y. Left underneath is y. And then we'll pull out a x. Left underneath is a x. Anything you pull out, you multiply. Anything left underneath it, you multiply. 14 times 3. 42yx, square roots of 2yx. So then you say to yourself, do I need absolute values? Yes. Even root, odd exponent. Let's look. Even root, odd exponent right here and right here, correct? So we need absolute values around those. We don't have to write in the power of 1, but I was just making sure you could see that those are odd exponents, yes. If it's an odd exponent, then yes. So that's the only time. Even root, odd exponent, you need absolute values no matter what. Does that make sense? If it says in the instructions to do it. Okay, finish up 1 through 24 on second page. Go. So we learned last time how to look at something like this. Now notice something. Look at this example. 75 over the square root of 3. This is not under radical, this is. Does everybody see that? So you would have to say to yourself, I can't put those together, but that's not considered simplified. Wouldn't we rationalize the denominator? We learned this last time, right? What would I need to multiply by? Square root of 3. Don't say 3, that's wrong. It's the square root of 3 that we're multiplying by, correct? So then we need it to be 3 squared on bottom. So we have 75 square roots of 3 all over the square root of 3 squared. So don't we have 75 square roots of 3 over 3? Does 75 divide by 3? Nope, so we're done. Okay, look at 25. Notice something. The difference between that problem, 25, and this problem isn't your 75 under the square root? So what you can do, and you will want to do this, is first put them together and see if you can simplify them first. So because these are both under the root, just like with multiplication, these are split up. Let's put them back together. 75 over 3. What is 75 over 3? Oh, this one doesn't simplify. What is it? 25 times 3 is 75. Okay, so that does simplify then. Right, so three quarters, guys, like a quarter, like a dollar. Okay, so that's 1 over 25. Bless our hearts. Okay, so right here, isn't this the square root of 25? Which is 5. Do you see how much easier that was than rationalizing the denominator? Putting them together, simplifying, and then seeing if you need to. Does everybody see? Okay, let's do another one. Look at 28. Notice we have a 6, a 3, an x, and an x. So couldn't we simplify first? They're both under a radical, so let's put it together. We have 6x over 3x. Now let's simplify it. What's under my root? 6 over 3 is? X over x is? 1. So 2 times 1 is square root of 2. Isn't our answer the square root of 2 then? We can't simplify it, correct? All right. Let's do 29. We have a cube root of 4x squared divided by the cube root of x. Can you put them together and simplify? Cube root, right? We can. Let's do that. Cube root of 4x squared over x. So that simplifies to be the cube root of 4x. Then you'd say to yourself, does it simplify? 4 breaks down into 2 times 2, so it doesn't look like it, correct? So my answer is this. So notice we haven't had to rationalize the denominators on any of these, right? So you wouldn't want to do that. You wouldn't be wrong, but then you're going to be simplifying a lot more than you should have been. Okay, let's do 31. Once again, they're both square roots, so let's put them underneath the same square root and simplify, and then look at our answer. So we would write this as the square root of both 2 and x squared divided by 5 and y to the 4th. Now we would have to be careful because isn't 2 to the 2nd power as well? So this is really the square root of 2 to the 2nd power is 4x squared, and then on bottom we have 5 to the 4th power. Go, try this. So we have 4 over 625, and then we have a y to the 4th. Is everybody good up to here? Now we say to ourselves, that is my answer unless it simplifies. Well, let's simplify it in sections, right? We split it up. What's the square root of 4? 2. What's the square root of x squared? X. What's the square root of 625? Type it into your calculator. 25. What's the square root of y to the 4th? Now you'd say, okay, so sweet, I've simplified all this. Can anything else simplify? Nope, right, we're done. Now notice there's not a radical anymore on bottom, so we wouldn't have to rationalize or anything. Everybody good with that? Okay, so you're going to do 25 through 33. So this is number 32. You simplified it to get this, and then unfortunately, we couldn't take the cube root and have it come out evenly. So that's what happened with the others, is they came out nicely with no radical, but this one has a radical still. So if you think about it, this is technically this. Cube root of 3y over the cube root of 2. Is that answer an acceptable answer? No, we can't have radicals in the bottom, correct? So we rationalize the denominator. So how many more 2's do I need? 2 more to get it to be 2 cubed. So we're going to multiply by the cube root of 2 times 2. I need to do it to the top. Cube root of 2 times 2. So now on top, we have a cube root of this and a cube root of this. So you'd multiply it all together, and there's not 3 of anything. So on top, we have the cube root of 3 times 2 times 2. What's 3 times 2? 6 times 2 is? So we have a 12y on top. And on bottom, what we technically have, I'm going to do it over here, we have the cube root of 2 to the cubed, correct? So doesn't root cancel out power. So this would be the acceptable final answer. So even though you got here and you said, yeah, that is my answer, but then you said, oh, well, actually it's not an acceptable answer because it still had a radical on bottom. We're notice on 31, once we simplified the square root, there was no radical. So that's why we didn't have to do anything with that one. Does that make sense, everybody? Okay, we'll have an extra practice with that on the next section next time. So.